All right, so just to kind of give you a little walkthrough and some help on the Deltamath, we're going to look at the key features that we talked about previously. So, as always, these are listed. Some of them are not in the same order that we've always done, but it's okay. You don't have to necessarily answer them in the order that they're listed. So for the horizontal asymptote, so remember the horizontal asymptote has to do with the degrees. So we're going to look at the degree of the numerator, the degree of the denominator. So they are equal. So when they're equal like that, that means that you're going to take the leading coefficients. So the leading coefficient of the numerator is 1. The leading coefficient of the denominator is -2. So we have a horizontal asymptote at -1/2. Now, if you didn't have one, like if you were looking at it and they were greater than, then you would just click no horizontal asymptote. Now, the vertical asymptote. So remember, in order to do the vertical asymptote, so the vertical asymptote and the x-intercepts and the holes down here at the bottom, those have to all be after we factored. Now, the y-intercept, we can do the y-intercept. We can do that by dividing the constants. This one has a constant of 0, so technically that's +0, and so does this one. So we know that the y-intercept is going to be at 0. All right, so the rest of these, in order to complete these, we're going to need to actually factor. So we're going to go through and let's factor this. So first part, we should see that there's a GCF. So we have x plus 5 in the top, which can't be factored any further. And then in the bottom, we have -2x squared plus 4x. Now, because of the negative in front, I would pull the GCF of -2 out, and that would be -2x. And that's going to leave me with positive x minus 2. So, at this point, what can we cancel out of this? Well, we always need to recognize that I can cancel the x plus 5s or the x minus 2s. Those are easy to see. But I also have an x and an x in common. Those can be canceled out of the problem. So because I can cancel that x out, that means that there is a hole that's located at x equals 0. Because we can still set that equal to 0. And so that's going to be located at 0. But what else is left? They're going to want you to tell the entire point. So what's left is x plus 5. And then in the bottom, we have -2 and then x minus 2, because we took those x's that were not in the parentheses and we canceled those out because they were a common factor. All right, so how do I find the rest of the point? Well, we find the rest of the point by substituting in the x pieces. And so we're going to say that we have y equals, and we're going to substitute in 0. We're going to say 0 plus 5. Remember, we do this in the simplified version. And then that's going to be 0 minus 2. All right, so that's going to give me 5. And then 0 minus -2 is still going to be -2 times -2 is going to be 4. So my hole is going to be located at 0 and then 5 over 4. All right, so now that we've done that, we need to now say, okay, what's left? Well, the vertical asymptote is what's left in the denominator. Now, this doesn't have an x anymore because we canceled that out right here. So because we don't have that left, all we're going to do is look at the x minus 2 piece. So we're going to say x minus 2 equals 0, so x equals 2. So we have a vertical asymptote at 2. And then what's left in the numerator, x minus 5, that's going to be my x-intercept. So x plus 5 equals 0. So we have x equals -5. And again, you can verify all this information graphically. All right, so we put in the problem. We can check everything we want to check. So if I look here, we can see at 0, it is undefined. Okay, and we said that that was located at 0 and 5 over 4. We can see that that's where that is located. There was an x-intercept at -5, which is also what we got. My vertical asymptote was located at x equals 2. We do have a vertical asymptote there. Now, we said the y-intercept was at 0 and 0. Now, if I'm looking at the y-intercept, we can't have a y-intercept at 0, 0 because there is a hole there. So, technically, if we have a hole there at 0, 0, then that means that for this one right here, we're going to have to say that there is no y-intercept. And now that I think back on it, that is exactly correct, because if I have 0, 0, so we said, okay, there's a 0 in the numerator and a 0 in the denominator. Well, we still can't have a 0 in the denominator, so that was completely my mistake when I said this earlier. So that's going to be undefined. So if it's undefined, that means that we're going to say that there is no y-intercept here. Okay. All right, so that makes more sense now. I think the last thing, we had a horizontal at -1/2. So y equals -1/2. And we can see, in fact, that that does have a horizontal asymptote at -1/2. All right, so once you get done with each problem, you can always kind of check in and see what are your key features through Desmos. So same situation here. Horizontal, again, remember horizontal means that we're checking the degrees, so these are equal this time. It's not always going to be equal. I know a lot of the ones that we have done. So we're going to say that that's going to be the leading coefficient, which is -5/4. This one has a 0 and a 0. So remember, we just kind of went back and reevaluated that. When we have 0 divided by 0, that means it's going to be undefined. Because we can't have 0 in the denominator. All right, and the rest of these we're going to need to factor to complete this. Okay, so if we factor this, we're going to take out a negative in front. So that's going to be -5x, and that's going to leave me with x minus 2. And then in the bottom, I have just 4x squared. Now, again, this is where it can be a little tricky for some, but if I look at this, I have -5x and x minus 2, and I have 4x squared, which is technically 4 times x times x. So I do actually have a hole here. I do have something in common. I have 1x, because that x squared means I had 2 of them, but I'm only able to actually take out one of those x's. Okay, so keep that in mind, that we're only going to be removing one of the x's. So since we're taking out one of them, that means x is equal to 0. Okay, so that leaves us with -5 x minus 2 and then 4x. Now, we want to find the actual location with the entire coordinate, so we're going to substitute in 0. So everywhere I see an x, I'm going to substitute 0 in, which is the x value that we got for the hole. And we make sure we do this in the simplified version. So with that being said, we have +10, but that's going to be over 0. So technically, that's going to be undefined. Okay, so what does that actually mean? So if it's undefined and I can't give you the exact y value, that means that there is no hole. All right, so let's look at it graphically. All right, so we have negative 5x squared plus 10x plus 4x squared. All right, so if I go to, we said that there was a hole at x equals 0. Well, what do you notice at x equals 0? Well, technically, we never are going to have a x value at 0 because there's already going to be a vertical asymptote. There's x equals 0, which is already there. So why doesn't the hole exist? Well, the hole doesn't exist because there's already a vertical asymptote there. That y value can't exist there. So we would put no hole, and we're going to say that there's no hole because there's a vertical asymptote left over at x equals 0, because that's what was left in the denominator. So that x right here means that there is a vertical asymptote which overrides the hole itself. Okay? So we can now say that that hole doesn't exist because, again, it's overridden by the vertical asymptote. So we have the x-intercept. So the x-intercept is whatever is left over in the numerator. So we're not going to use the negative 5, but we are going to be looking at x minus 2. So we have a x-intercept at positive 2. So if we go check that out, we can see that that crosses at positive 2. And then the y-intercept. So we already said the y-intercept doesn't exist because it's never going to, there's a vertical asymptote at the y-axis. And the horizontal asymptote is at y equals negative 5 over 4. So we can see that as well. So in this situation, this one kind of was a little funky because that vertical asymptote overrid the hole that was there. So just keep in mind that if you ever have that issue where it becomes undefined like that, it's because there's a vertical asymptote there. And then there's no y-intercept as well. All right, so then there was some individuals where it says find all of the vertical asymptotes. So remember, the vertical asymptotes are the pieces that are left in the denominator after it is factored and canceled. So if we figure out our factors here, we got negative 20, but have to add to give me 8. So we have negative 2 and 10. So this is going to be x minus 2, x plus 10 in the top. And then in the bottom, we have a GCF of 2, so that's x plus 10. So we can cancel the x plus 10s, but remember the x plus 10s are the holes. They want the vertical asymptotes. So what's left over in the denominator? Well, in the denominator, the only thing that's left over is a single 2. There's no x. So therefore, there is no vertical asymptote. You got to have an x here. You can't have a vertical asymptote without having an x value there. So there's no x left in the denominator, so therefore there is no vertical asymptote. All right, so again, vertical asymptote. If we're looking for the vertical asymptote, we're looking for what cancels. So this is already in factored form, so we can cancel, oh, wrong one. We can cancel the x plus 10, or 3x plus 10, 3x plus 10. So what's left over in the denominator, because that's what we're doing, we're not doing vertical, we're doing horizontal. Let me backtrack. So if it's a horizontal asymptote, that's the degrees. So this is in factored form, so we need to make sure we know what the degree is. So this has a degree of 2, because there's 2 x's. This one also has a degree of 2. So they're equal to each other. So what are the leading coefficients? Well, the leading coefficients are going to be what I get when I multiply these two together and these two together. So that's going to give me 9x squared and 3x squared, right? So that means that my horizontal asymptote is going to be y equals 3. So just keep that in mind. If it's in factored form, just multiply the pieces together. That would make the leading coefficients. All right, so the x-intercepts. So the x-intercepts are what's going to be left over after you've canceled all your pieces out. So we're going to factor. So GCF, we have x minus 1 after we take out that GCF of x. And then in the bottom, we need to do the multiples of negative 15 and add to give me negative 2. So we're going to have 3 and negative 5. All right, so we actually don't have anything that we can cancel here. But the x-intercepts are what's left in the numerator. Now we have two x's that are left in the numerator. We have this x and we have the x minus 1. So we have x equals 0 and we have x minus 1 equals 0, which means it's x equals 1. Now it does say that they want you to write it as a coordinate point. So this is going to be 0, 0, and this is going to be 1, 0. And again, you would need to do the drop-down menu, and you're going to want to select the one that says you have two x-intercepts. All right, y-intercepts. So remember, the y-intercepts are the leading, or excuse me, not the leading coefficients, the constants. So we have a constant of 16 and negative 36. So if we divide those, all right, so they're both divisible by 4. So that's going to be 4 and negative 9. So we know we have one y-intercept, and that y-intercept is, they want it to express it as a coordinate, so it would be 0 and negative 4 over 9. All right, and then the whole. So this one's a little bit bigger of a problem. So for this one right here, they're in the numerator. Remember, the wholes are what we can cancel. We do not have a GCF, so we're going to need to slide and divide this whole problem. So if I multiply 5 to 27, that's going to give me 135. So this is going to be x squared minus 42x plus 135. So we're going to be looking for the multiples of 135 that add to give me negative 42. And you're just going to have to go into Desmos and divide it out until you can find. So you can do, so if I do 135, obviously divided by 5, that's 5 and 27. If I do divided by 3, well, actually 3 works. It's going to be 3 and 45. So you just have to divide it until you figure out which ones are actually going to work, but we need to make the 45 negative. So if I set this up, that's going to be x plus 3 and then x minus 45. But since we did slide the 5 over, we need to divide by 5 and simplify. So bottoms up, so this is going to be 5x plus 3. And then 45 divided by 5 is going to be x minus 9. All right, so over here, we have a GCF of 2. So that's going to give me x squared plus x minus 90. And we are going to need to GCF that as well. Or excuse me, not factor that as well with the slide and divide, but we already took out the GCF of 2. So multiples of 90, that's going to be negative 9 and 10. So my final factored form all right. So my wholes are going to be in the x minus 9. That's what they have in common. So we know initially that x minus 9 equals 0. So x equals 9. Now, it says if a whole exists, write your answer as a coordinate point. So if we're going to write it as a coordinate point, we got to have the y value. So remember, the y value is going to come from the simplified form and us substituting in. So the simplified form is going to be 5x plus 3 divided by 2 times x plus 10. So wherever we see an x, we're going to substitute in 9. So that's going to be 5 times 9 plus 3 divided by 2 times 9 plus 10. And if you need to put it in Desmos, you can put it in Desmos. So we got 5 times 9, that's going to be 45. So that's going to be 48. And then 9 plus 10 is 19. And then we have 19 times 2. So once we kind of put that all together, we're going to simplify that. And I got 24 over 19. All right, so 24 over 19. And again, we can check that in Desmos the same way we did previously. So we have y equals, and we got 5x squared minus 42x plus 20, oh, what was that, 20 minus 27. And then on the bottom, we had 2x squared plus 2x plus, or minus 180. All right, so originally it said that our whole was at 9. So if I go to 9, we can see it's undefined right there. And then I can put in my 0.9, and we got negative, or not negative, 24 over 19. And that's where it does show that whole, what we just found. So you can always check that when you need to. All right, if you have any additional questions, there's always YouTube videos that can help you through these, or please message me.